Hello, Assalamu alaikum. My name is Syed Mohammad Asadullah. I am a student of COMSATS University Islamabad WA campus. I did my bachelor's in electrical engineering. My final year project is on electromagnetic railgun under the supervision of Dr. Aamir Qamar. In this video, I will give detailed brief on my final year project, which is electromagnetic railgun. But before going in its detail, we will discuss what is an electromagnetic railgun. The electromagnetic railgun is an electrically powered electromagnetic projectile launcher. Electromagnetic railgun is an emerging technology. A railgun is a linear motor device typically designed as a weapon that uses electromagnetic force to launch high velocity projectiles. The projectile normally does not contain explosive, instead relying on the projectile's high speed, mass and kinetic energy to inflict damage. The electromagnetic railgun is an electrically powered electromagnetic projectile launcher, as its name shows, gun in which a pair of rails is used. It is an entirely electrical gun that accelerates a conductive projectile along a pair of metal rails using the same principle as the homopolar motor. Conventional guns use high pressure to accelerate a projectile by applying pressure inside a barrel. Such high pressure is generated using the expansion of gases through combustion, but due to expansion limits of gas, achieving high velocities become a constraint. Because of such limitation, projectiles shot from conventional gun can barely reach velocity up to 1300 meter per second. But by using electromagnetic railgun, velocities as high as 20,000 to 50,000 meter per second can be achieved. Electromagnetic railgun such ability make it desirable future weapon for shooting long range targets. Now we move towards working principle of electromagnetic railgun. As we know, electromagnetic railgun is consisting of two metallic rails, and between them there is a moving armature or a projectile. When we supply electric current start flowing from one rail. A movable armature play bridge role between two rails, and current start flowing in another rail as well. We know that current flow from conductor produce magnetic force. When magnetic force generates, this magnetic force known as Lorentz force acts on a projectile and make projectile to move in forward direction. Now we see its working principle in detail. An electric current runs from the positive terminal of the power supply up to the positive rail, across the armature and down the negative rail back to the power supply. Current flowing in any wire creates a magnetic field around it, a region where a magnetic force felt. This force has both a magnitude and a direction. In a railgun, the two rails act like wires with a magnetic field circulating around each rail. The force line of the magnetic fields run in a counterclockwise circle around the positive rail and in a clockwise circle around the negative rail. The net magnetic field between the rail is directed vertically. Like a charged wire in an electric field, the projectile experiences a force known as the Lorentz force. This Lorentz force makes a projectile to move in a forward direction. The Lorentz force is directed perpendicularly to the magnetic field and to the direction of the current flowing across the armature. The Lorentz force is parallel to the rail, acting away from the power supply. The magnitude of the force is determined by the equation F is equal to ILB. The force can be boosted by increasing either the length of the rail or the amount of the current. One more thing, when the projectile moved in forward direction, length for current to flow in both rail increases, which increase the density of magnetic force in both rail. As the density increases, Lorentz force acting on a projectile also increases, which increase the speed of a projectile. Here is a small comparison between electromagnetic railgun and a conventional launcher. Range of electromagnetic railgun is of 200 miles and above, while the range of conventional launcher is of 20 to 80 miles. Electromagnetic railgun launch a projectile with hypersonic speed, which is about 5 to 7 times faster than the speed of sound. while a conventional launcher launch a projectile with a speed of sound. Conventional launcher have some limitation, like explosives have limit up to which they can provide speed to the shell, while there is no such speed limit in electromagnetic railgun. Here is a fun fact that capabilities of electromagnetic railgun are even greater than that of a missile like Tomahawk, BrahMos, Ghaznavi, and Abdali Hataf 2 in terms of speed and its range. Now we will discuss the objectives of electromagnetic railgun. Electromagnetic railgun, as its name shows, works on two rails and it's completely electrically powered projectile launcher. Other conventional launcher required many mechanical work involved and many combustion of gases to launch a projectile. These mechanical work and combustion of gases cause many limitations and increase the conventional launcher projectile speed and range. While on the other hand, electromagnetic railgun is completely electrically powered projectile launcher required only electrical power to launch a projectile. So it is easy to achieve Mach 5 to Mach 7 speed with electromagnetic railgun. With its speeds, its range is also multiple times greater than conventional projectile launcher, such as electromagnetic railgun is much more effective than Pakistan existing Ababil and Hataf 1 missile system in terms of speed and range. Normally, a conventional launcher is used to target area under 100 to 140 km, but to target area more than 140 km, missiles are used, which are more costly because they require more proper engine mechanism for flight. So, to overcome this issue, the researchers are working on electromagnetic railgun which provide speed of Mach 5 to Mach 7 and can hit the target over long distance up to 300 km. Objective of electromagnetic railgun is also to achieve high rate of firing. Conventional projectile launcher has relatively less fire rate than electromagnetic railgun. Now, here we discuss the methodology we use to develop a prototype of electromagnetic railgun. Our project is divided into two phases: mathematical analysis and practical implementation. In first phase, I complete a literature review and on that basis completed mathematical analysis in which we done analysis on following questions: how much minimum magnetic field required to launch a certain specification like mass, resistivity, etc. of projectile, how much minimum current and voltage required to launch a certain specification of projectile, how much air drag and friction act on our projectile during its flight. In our research, we found that we have to supply large amount of current in short period of time. To get required current, we use high volt electrolytic capacitor which provide required current in short period of time. Therefore, we done mathematical analysis on how much capacitor value required. We use 18 capacitors of 3300 microfarad capacitance which have 400 working voltage capacity. For the second phase, that is practical implementation, we design a capacitor bank of 18 high voltage electrolytic capacitor which is used to supply a required current instantaneously. Above that capacitors, there is the rail setup which provide mechanism to launch our projectile. On rails, we use heavy resistors to discharge our capacitors in case when our electromagnetic railgun is not working. We also install capacitor voltage monitoring system to control or monitor the amount voltage charge in capacitor while charging. Here is the basic version of circuit diagram which we use in our prototype. Charging unit is used to charge the capacitor bank. When the switch is closed, capacitor bank provides large amount of current in short period of time. When the current flow from our metallic rails, electromagnetic field is produced. When electromagnetic field produced, Lorentz force is also produced which make our projectile to move in forward direction, as we discussed in its working principle in previous slides. Here are some applications of electromagnetic railgun. Electromagnetic railgun can be used in navy warships, cannons and submarines. Electromagnetic railgun can be used in army tanks and artillery cannons due to its high firing rate or firing speed. Electromagnetic railgun can be used in defense systems like anti-missile, anti-aircraft system, missile launchers. Apart from all its application in defense sector, electromagnetic railgun can be used in launching space rockets, spaceships. Concepts of electromagnetic railgun can be used in electric trains. Now we discuss the advantages of electromagnetic railgun. Electromagnetic railgun throws a projectile at long range. Its projectile velocity is much faster as compared to conventional launcher. It is durable. It has inexpensive projectile as it does not require any explosive in it. It has less recoil as compared to conventional launcher because there is no expansion of gases in it. Electromagnetic railgun projectile provide greater damage as it speeds it faster. Here are some limitations of electromagnetic railgun. Maintaining the structural integrity of the rails as they undergo such stressful conditions. The thermal management of the entire system, especially as the rail increases in size, need to improve. The system is bulky. Charging time of capacitor is high, which increase the rate of firing of an electromagnetic railgun. After doing final year project on an electromagnetic railgun, I have conclusion that railguns are a very intriguing technology and have several exciting potential applications. While the physics of the electromagnetic phenomena are fairly simple, implementation of the technology has proven to be very difficult. The future of railgun development depends not only on continued development of technology but also on continued financial support of electromagnetic railgun research. Here is a prototype of an electromagnetic railgun. As we knew that electromagnetic railgun is consist of two metallic rails and a capacitor bank. This capacitor bank is used to provide large amount of current to the metallic rails in short period of time. As we see here, these capacitors are used to make a capacitor bank. We use totally 18 capacitors to make a capacitor bank, and each capacitor has a capacitance of 3300 microfarad and have 400 working voltage capacity. This is the charging unit for the capacitor bank. These metallic plates are used to connect these capacitors in a parallel combination. These metallic plates also used as a base for a barrel. Inside the barrel there are two metallic rails. Each rail is made up of copper. When a large amount of current from the capacitor bank flow from these rails, electromagnetic field is produced. When electromagnetic field is produced, it produces a Lorentz force which causes a projectile to move in a forward direction. We discuss its detailed working in a previous slides. The length of a barrel is of 1 meter. We use this 16-gram ball bearing as a projectile. Now we move to experience the firing of this electromagnetic railgun. This brings me to the end of my video. Here is the end of brief on electromagnetic railgun. We discussed electromagnetic railgun thoroughly, its working, its objective, its socio-economic impact, its methodology and its applications. I want to conclude my video with Albert Einstein quotation. He said, "Innovation is everyone's responsibility, not just R&D's." That's all from my side. Thank you for your precious time. Take care. Bye bye. Allah Hafiz.